Tonight, on The Future of Everything, we explore one of the most extraordinary moments in modern astronomy, new updates on 3I, Atlas, the third confirmed interstellar object ever found drifting through our solar system. On October 4, 2025, something remarkable happened on Mars. NASA's Perseverance rover, while navigating Jezero crater, captured a thin, glowing streak crossing the red sky. The rover's navigation camera isn't meant for astronomy. It's designed to avoid rocks and sand traps, yet that night, it recorded what looked like a perfect beam of light slicing through the Martian atmosphere. At first, some thought it was a glitch or a meteor. But data confirmed it wasn't. It was 3I, Atlas, a visitor from another star system, and its appearance was unlike anything scientists expected. The image sparked confusion. Perseverance's camera isn't built to photograph distant objects, so at the comet's distance, about 38 million kilometers from Mars, each pixel represented nearly 12,000 kilometers of space. That means the glowing streak appeared nearly 50,000 kilometers long, far beyond the size of any known comet. Yet, observations from the Hubble Space Telescope in July 2025 showed nothing that massive. Hubble saw only a faint, unresolved dot of light. The most likely explanation? Motion blur. To capture such a faint target, the rover's team had to combine many short exposures. During that time, 3I, ATLAS moved slightly, creating the illusion of a long, luminous streak. But that image wasn't alone. The Mars Reconnaissance Orbiter and other spacecraft also turned their instruments toward the same region of sky that night. For a few hours, 3I, ATLAS became one of the most closely observed interstellar objects in human history, tracked from both the Martian surface and orbit. The image that could settle the debate, the one taken by the orbiter's high-rise camera, capable of 30-kilometer resolution, may finally reveal its true size once NASA's data blackout ends. Ironically, that blackout happened right as the comet was at its closest. Due to a government shutdown, NASA's communications went silent, just as the world needed answers most. The pause only fueled speculation. Some astronomers think 3I, ATLAS is simply an extremely active comet behaving in strange new ways. Others wonder if it's something more, a probe, a fragment, or an engineered object. Astrophysicist Avi Loeb, known for his controversial views on interstellar objects, has proposed that 3I, ATLAS might not be entirely natural. He points to its precise trajectory, its unusual nickel-rich composition, and its apparent mass as potential clues. Still, NASA's position is cautious and grounded. All evidence so far suggests 3I, Atlas is natural, a rare but genuine interstellar comet. Yet, questions remain. Around September 25, a violent solar eruption slammed into the object. Instead of disintegrating, it became brighter and accelerated, soaring past 60 kilometers per second. Even more surprising, the glow extended ahead of the object, toward the sun, the opposite of what's typical for comets, whose tails trail behind them. That glow may be the result of charged gas interacting with the solar wind, or something stranger altogether. Meanwhile, other missions, ESA's Mars Express, the ExoMars orbiter, and even the JUICE spacecraft on its way to Jupiter, have locked onto 3I, ATLAS to collect spectra and particle data. Solar interference will delay some transmissions, but once complete, we'll have the most detailed dataset ever recorded for an interstellar visitor. To understand its structure, researchers at Harvard University analyzed data from 227 observatories worldwide. They found a faint but consistent acceleration, caused by outgassing jets, too small for such a visibly active comet. That means 3I, Atlas is heavier than expected, roughly 5 kilometers wide and weighing more than 30 billion tons. It's far denser than any interstellar object detected before, making it a genuine cosmic outlier. And that leads us to a bold and fascinating idea, one proposed by astrophysicist Dr. Suzanne Falsner. She believes 3I, ATLAS might not be just a lonely wanderer drifting through space, but something far more significant, a seed of creation. A fragment born in another star system, now crossing the void, carrying the raw ingredients of worlds yet to form. In her view, interstellar objects like 3I, ATLAS may play a hidden role in cosmic evolution. They're not simply visitors, they're messengers from long-dead stars, survivors of cataclysmic origins, and perhaps, the very sparks that light the process of planet formation wherever they go. To understand her theory, picture a young star surrounded by a swirling protoplanetary disk, a vast cloud of gas, ice, and dust rotating in delicate balance. Inside that disk, countless grains begin colliding and clumping together. Over millions of years, these collisions grow pebbles into boulders, boulders into mountain-sized fragments, and eventually, into the first planetary cores. But there's a problem: time. These disks don't last forever. Powerful stellar winds from the newborn star blow away the gas long before planets can fully form. It's a cosmic race against the clock. How could giant planets like Jupiter or Saturn have formed so quickly before their raw materials vanished? That's where Falsner's idea changes everything. She proposes a shortcut in the grand design of creation. Imagine a mature interstellar object, like 3I, ATLAS, entering a young star system at just the right moment. Instead of starting from microscopic dust, the system suddenly gains a ready-made planetary core, forged in another corner of the galaxy. This intruder instantly becomes a gravitational magnet, pulling nearby gas and debris toward it, accelerating the birth of a brand new world. It's a breathtaking possibility, that planets may not always start small. Some might be born from ancient wanderers that drifted between stars for eons, until captured and reborn in a new system. In this sense, the universe may recycle its building blocks endlessly, one star's debris becoming another star's destiny. Falsner's simulations back this up. Her computer models show that massive stars, with stronger gravity and wider disks, are far better at capturing these interstellar nomads. And when astronomers look at the data, a curious pattern appears. Gas giants, the largest planets we know, tend to orbit larger, more massive stars. It's as if the universe itself remembers this rule. If this is true, then objects like Oumuamua, Borisov, and 3I, ATLAS aren't just passing through. They could be part of an ancient galactic network, a chain of cosmic seeds scattering through the Milky Way, igniting new worlds wherever they land. Each interstellar object might carry within it the fingerprints of its parent system, minerals, ices, and molecular codes that once belonged to another sun. When such an object joins a young disk, it doesn't just help form planets. It blends cosmic histories together, weaving the story of one star into the next. It's a poetic idea, that worlds may not have a single birthplace but many. That our own Earth, in some small way, might carry fragments of ancient, far-off systems, traces of other suns long since extinguished. If so, we're not just made of stardust, we're made of shared stardust, passed between generations of stars like a cosmic inheritance. And now, as 3I, ATLAS sails toward the sun, glowing softly against the black, it carries that mystery with it. It doesn't roar or flare. It drifts in silence, steady and graceful, as if it knows its journey has meaning beyond comprehension. Its coma, that hazy halo of ionized gas, stretches ahead rather than behind, defying expectations, almost like it's reaching forward into the light. Every telescope, every orbiter, and every rover watching it is part of a moment that may reshape how we understand planetary creation. Because each time we encounter one of these interstellar visitors, we're not just studying an object, we're reading a message. A message written in chemistry, motion, and light, whispering how worlds come to be. Maybe this is how the universe builds its beauty, not in isolation, but through exchange. Stars die, their fragments drift, and in time, those fragments become the seeds of new beginnings elsewhere. A never-ending cycle of loss and rebirth, of endings turning quietly into origins. For now, 3i, ATLAS continues its silent flight toward the sun, enigmatic, steady, and calm. But every pixel of light we capture, every spectrographic line we decode, brings us closer to understanding what it truly is. And as we follow its journey, one truth grows impossible to ignore. Each interstellar traveler that enters our skies is more than a visitor. It's a reminder that the universe itself is alive with connection, creation, and continuity. That somewhere out there, among the stars, new worlds are already forming from the echoes of the ones that came before. And in that endless cosmic cycle, perhaps, lies the reason we're here to witness it.